Now we're going to talk about our transition metals, where they are groups 3 through 12. So those are columns 3 through 12. Remember, if you numbered your columns going across 1 through 18, we're talking about that middle group, 3 through 12. These guys do exist in elemental form, so you can find an atom of carbon or zinc or whatever. And the reason that happens is because they are more stable than groups 1 and 2. These guys have 1, 2, or 3 outer electrons or valence electrons. So when you draw their atoms, that last ring that you draw, they're going to either have 1, 2, or 3 electrons there. And the big deal about transition metals is that they have multiple oxidation numbers. And you probably haven't heard that word, but it is just a synonym for charges. So we're going to learn a lot more about that in chapter 20. But just remember that transition metals are known for having different charges. So for example, if you have a copper atom, it could have a +1 charge, and you could have another carbon or copper atom that has a +2 charge. So those are different ions, and they have multiple different oxidation numbers. And one more thing about transition metals is that they often form colored compounds.
When an yttrium disk is cooled with liquid nitrogen, the yttrium's electrical resistance is reduced to 0, and the disk becomes a superconductor. A superconductor will repel any magnet brought near it. This is known as the Meissner effect. Normally, one magnet will attract another magnet with the opposite pole and repel a magnet with the same pole. What is unique about the Meissner effect is that the yttrium is not actually a magnet. It repels this gold-coated neodymium magnet like a mirror. The yttrium mimics neodymium's magnetic poles so that the same magnetic forces are reflected back and the magnet is kept in suspension.
Okay, so let's talk about the iron triad. The iron triad consists of iron, cobalt, and nickel, and you'll need to know those. And what's important about them is they're used to create steel. And steel's really important for us in our society because steel is used as a very strong metal to create all kinds of buildings and structures. Iron is the main component.
In this experiment, aluminum metal is combined with iron oxide to produce a stream of molten steel. The mixture of iron oxide and aluminum is ignited with a burning sparkler, and the energy released causes the metals to melt until a pool of molten iron forms. This process is called the thermite process. It was invented more than 100 years ago to make strong welds between metals, such as when molten iron is poured between the rails of a train track to form a permanent weld.
Okay, let's talk about copper, silver, and gold. They're the first 3 elements in group 11, and they were often used to make coins. And the reason they was because they're stable. You know, they're not going to react with anything. They're malleable, which means, remember, they can be pounded into sheets. Now, they're not as thin as aluminum foil, obviously, but they can be pounded down pretty thinly. And because they're found in free elements in nature, so you can go mining for gold or mining for silver or mining for copper and find it pretty readily. Now, you might know this, but copper is used in electrical wiring. And the reason why copper is used for that is because it's a good conductor and it's fairly inexpensive, especially compared to silver and gold. And silver is used in photography. And the reason why is because it can easily be broken down to produce an image on paper.
A wire pulling die with a series of reducing diameters increases the length of copper wire from 10 inches to 15 inches as it is simultaneously thinned. Beeswax applied in between each draw provides lubrication.
Solid silver is very malleable, ductile, and has a brilliant white lustrous appearance. Here, skilled silversmiths are working the metal to make a necklace. They cut, drill, file, and solder it. Silver is a popular metal for use as jewelry, coinage, and household objects.
Okay, we have zinc, cadmium, and mercury, and they're grouped 12 elements. Zinc and cadmium are used as protective coverings on other metals. And that's because when they combine with oxygen, a thin protective coating is made. Cadmium is also used in rechargeable batteries. You may have heard of that before. Mercury is super dangerous. Some of us might have talked about mercury as being poisonous to us. Mercury is a silver metal, and remember that's the only one that's liquid at room temperature. Remember from Alice in Wonderland, you have the Mad Hatter. He's a character from the Mad Hatter, and they used to make hats with felt, and they used mercury. And so what would happen was the person that was making the hats would go mad and go crazy. And so they coined the phrase Mad Hatter.
Zinc is a gray metal with a pronounced blue tinge. Here, zinc balls are melted and the crust removed. The molten zinc is then used to create animal shapes in a mold. The metal is non-toxic and has a low melting point, which makes it suitable for casting various shapes.
Okay, so now we're going to talk about the inner transition metals. And these are the two rows at the bottom of the periodic table. And some people ask why these are at the bottom, and this most simple answer is because if not, the periodic table wouldn't fit on one piece of paper. And the other reason these specific elements are pulled out is because they have similar properties. The top row is called the lanthanide series, and one use for these elements are to produce colors in TVs. And the bottom row is called the actinide series, and all these elements are radioactive and unstable. Radioactive, remember that that means they break down really fast, and they are bad for us. So some metals are found in the Earth's crust, okay, and some of them are uncombined, like gold and copper. People used to say they were going to mine for elements, mine for gold, that's what they were talking about. And then other metals in the Earth's crust are combined with other elements, and those are called ores.